Hi everybody, it's Miss C to go over target 19 day 3, which is parametrics with conics, so circles, ellipses, hyperbolas, and parabolas. So let's start with this first example here. I'll show you how to plug it into the calculator if that's something you want to do. First, you got to check your mode. Let's just set it to degree and parametric, so I'm good there. My window, if I'm in degrees, we should go 0 to 360 to go all the way around. T-step means I'm just going up and getting a data point every 15 degrees. And then I'll go to my y equals and plug in x equals 2 cosine of t and y equals 3 sine of t plus 1. And then you do zoom square. You don't have to graph these, but I just want to show you this first one so you can see what it is before we actually go into it algebraically. So that looks like an ellipse. So the center looks like it's maybe like 0, 1, and it's pretty narrow. So let's actually think about how we could solve for this algebraically and make it look like standard form of an ellipse. With those linear equations, we would solve for t and then set them equal. But with the sines and cosines, we'll have to involve something a little different in order to combine and eliminate the t. And that method is our favorite trig identity, the best math love story ever, cosine squared plus sine squared. Okay, so I'm gonna just rewrite it quick with the squared on the outside because I can get cosine of t by itself. I can get rid of this 2 by just a quick dividing. So cosine of t is equal to x over 2. So that can be substituted out. So instead of having cosine of t, I can get rid of it and instead substitute in x over 2. Okay, and I'll deal with the last simplify step in a second, but let's go over and do the same thing for sine. I'm going to minus 1 and then divide by that 3. So sine of t is equal to y minus 1 over 3. So again, that's what I'm going to substitute in here. Okay, but keep in mind, like, we do have to go one more step. This isn't what standard form of ellipses usually looks like. Like this x squared on top is fine, but then I do have to change this to be 2 squared on the bottom, or 4. And then same thing for this other one here. I'll have y minus 1 squared, which I can leave because that's going to tell me my center point. But just make sure that I square both the top and the bottom. So that should really be 9. So now I have an ellipse. Its center point is at 0, 1. And you have your a and b values from your denominators here. So 2 and 3 here, which if I look at my equation, or excuse me, in my calculator, looking at that graph of the ellipse, it does match. Like in the x direction, I go left and right 2, and in the y direction, I go up and down 3 from the center point. So we had to use cosine squared plus sine squared equals 1, that Pythagorean identity, in order to get t eliminated. So if you would like to try 2 more of those, feel free to pause the video, and the answers will be posted in about 5 seconds. All right, so if you tried those, just notice on this example 2, if you stopped here and went to graph this ellipse, okay, it ended up having an equal a and b. So we know that that's actually a circle. So you could have gone one step further and times by 4 on both sides to make r squared of 4. But let's also go in the reverse. Let's start with standard form of, this would have been a circle with a center point at 1, 0, radius of 5. Okay, and let's actually get the parametric equations of it. So we've got to basically work in reverse here. So first, I would want this equal to 1. So that makes it equal to 1. And then I got to think of that step before here. Like this would have been x minus 1 with what on the bottom? What would have been squared to get you 25? Same thing here. What would have been in that denominator squared to get you 25? Or think, what is the square root of 25, which would be 5. So now this is, since it's x, this is what cosine of t was equal to. And this is what sine of t was equal to. And keep in mind, your end goal is, I want what x and y are equal to, so I'm trying to solve for these. So the sine of t one is real quick here. I'm just going to times by 5. So my y equation was 5 times sine of t. And to solve for x, I'll have to times by that 5 again. And then also just get rid of the minus 1 with the plus 1. So 5 times cosine of t plus 1. It doesn't like when I write in the corner of the board here, so it looks a little funny. But that's 5 cosine t plus 1. So here is one more that we can go through really quick. So it's already equal to 1, so that's good. So I'll have to think, what was this before it got squared? Same thing here. On the bottom, what would this have been equal to before it got squared? Well, for 4, that's pretty quick. It would have just been 2. Should keep my equals 1 here. This one's a little trickier. Root 7 isn't a nice number. So let's just leave it root 7, because root 7 squared, the root and the square cancel each other. Root 7 was a little funky here. So this is what my cosine of t would have been equal to. And this is what my sine of t would have been equal to. So to solve for our end goal to get into parametric, solve for x and solve for y, looks like I'll have to times by root 7 to get root 7. There's that corner again. I don't know why it doesn't like the corner. Root 7 cosine t. That is just a funky square root. There, I got it. And then to solve for y, I'll have to times by 2 and add that 5. So 2 sine of t plus 5. These are my parametric equations. That would give me that ellipse. So the homework for this is the day 3 required set, and there are, looks like 4 questions. Thanks for watching.